Okay, so this lesson really isn't a lesson in your textbook. It's just basically just one page at the end of this chapter. But I think it's important, so I wanted to go over this. It's called complex fractions. So a complex fraction is really just a fraction within another fraction. So if you look at our example here, we've actually got two different fractions in the numerator and two different fractions in the denominator. And there's two basic methods for solving a complex fraction, and we're going to go over both of them. And they're very, very similar, so they're almost interchangeable. Once you get used to using the two methods, you'll kind of automatically go to one or the other, whichever one seems to work best for you. So the first method says to simplify the numerator and denominator. That means this numerator and this denominator. Then you're going to express the fraction as a quotient using the division sign, and then you're going to multiply by the reciprocal of the divisor. So that sounds like a lot, but we're going to do it one step at a time. So if we start, the first thing it says to do is to simplify the numerator and denominator. So if I look at this first set of fractions in my numerator, my least common denominator is going to be AB. So basically, I'm multiplying this first fraction times B over B, and I'm multiplying the second fraction times A over A. So what I'm going to end up with is B over AB plus A over AB. Okay, so that's what I'm going to end up with in the numerator with my common denominator. I'm then going to simplify that, so I'm going to add them together, and it's going to give me, and I wrote down the wrong thing, it's going to give me B plus A over AB. Okay, so that's the numerator simplified. I'm now going to do the same thing with the denominator. I have B over 2A minus A over 2B. My least common denominator is going to be 2AB. So what I'm going to do is I'm going to multiply this fraction by B over B, and this fraction by A over A. So I'm going to end up with B squared over 2AB minus A squared over 2AB. And when I simplify that, I end up with B squared minus A squared over 2AB. Okay, so that is the numerator simplified and the denominator simplified, and I can actually put my fraction bar there. The second step says express the fraction as a quotient using the division sign. So what that means is I'm going to take my first fraction, divide it by my second fraction. Okay, which we know how to do that. So I'm going to go ahead and just simplify that. So I have B plus A over AB times 2AB over B squared minus A squared. I'm going to go ahead and factor this because this is the difference of two squares. So B minus A and B plus A. And now I can just, since everything is factored, I can cancel things out. So the B plus A's cancel out. This B and this B and this A and this A cancel out. This fraction has been reduced to 1. I'm left with a 2 in my numerator here and a B minus A in my denominator. So this is the final result. Okay, so I started by simplifying the numerator, simplifying the denominator, writing it then using the division symbol, doing my keep, change, flip, factoring, and then canceling out. And this is what I ended up with. Okay, the second method, let me move this up here, is very similar. The first thing you're going to do, though, is you're going to find the least common denominator of all the simple fractions. So I'm going to go ahead and rewrite this so you can actually see it again. So it was 1 over A plus 1 over B all over B over 2A minus A over 2B. So if I look at all the denominators, my least common denominator for all of them would be 2AB. Okay, and this method works really well when your denominators are similar. So here I've just got A's and B's and 2. So that one, this method works pretty well for this. So I find the least common denominator, and then I'm going to multiply the numerator and the denominator of the complex fraction by this. So here's how this looks. Let me rewrite this. If I multiply this times 2AB over 1, and I multiply this times 2AB over 1, I'm multiplying the whole fraction by 2AB over 2AB, which is just multiplying by 1, so I'm allowed to do that. But by doing this, I'm going to end up canceling out all of those denominators. So here, when I distribute, these a's cancel out and I'm left with 2b. When I distribute here, the b's cancel out and I'm left with 2a. Doing the same thing here, when I multiply, the 2a's cancel out and I'm left with a b and another b, so b squared. Here, the 2 and the b cancel out and left with an a, which gives me a squared. Okay. I'm then going to factor this. Now, I don't have to write it again using the division symbol because I just have one fraction. But if I factor it, I end up with this. And then when I cancel, I get 2 over b minus a. Now, you might say, well, this one worked much easier. And it did work pretty easy for this particular example. But there are going to be times when it's just easier to do the first method. So the first method is best when your denominators are very different. The second method works best when your denominators are very similar. All right, so let's look at this example here. Now here, my denominators are all pretty much the same, so I'm going to use the second method. So my LCD would be 8. So I'm going to multiply this times 8 over 1 and this times 8 over 1. And I'm going to end up with 2 plus 1 over 2 minus 1. Well, this is tough, which gives me 3 over 1. So that was pretty easy. I could have done it the first way where I simplified them first. If I did that, I would have, this would be 2 over 8, so I would have 3/8. And this would be 2 over 8 over 1/8. And then I would just have to rewrite it like this. Hopefully you would write it neater than I did. 3/8 times 8 over 1, the 8's cancel and you get 3. So in this case, the second method was just the easiest. So the first method works best when the denominators are very different, or maybe they're very complex denominators. You've got a bunch of variables and exponents and stuff like that. The first method would probably work best. The second method works best when the denominators are very similar, and that's complex fractions.